There is enough luminous matter in the universe to completely light up the night sky, brighter than the surface of the sun. If you add up all the photons spewing out of all of the stars and galaxies and the space in between, there is enough to light up the universe. Yet when we look up at the sky, this is clearly not the case. So, why is the sky dark at night? Many have been thinking about this for a long time. It can be traced as far back as Thomas Digges in the mid-1500s, Johannes Kepler in 1610, and even later by Edmund Halley in the 18th century. And curiously, even Edgar Allan Poe anticipated possible explanations as to why the night sky is dark. But it was not popularized as a paradox until German amateur astronomer Heinrich Wilhelm Olbers began to think about it in the 19th century. It became known, not surprisingly, as Olbers' paradox. Simply stated, Olbers' paradox says that if the universe is infinite and static, then at any given angle from the Earth, the line of sight will end at the surface of a star. An infinitely old universe means that there's been plenty of time for the light from every star that has ever shined to reach our eyes. When we look up, there should be a star everywhere, in every piece of sky. And because of this, the sky at night should be just as bright as when the sun is up. The explanation for why the sky is dark instead of a brilliant curtain of light comes from more recent observations and discoveries about our universe made since Olbers' time. In the 19th century, the nature of space-time and the large-scale structure of the universe was not yet understood. Indeed, astronomers didn't even know there were other galaxies besides ours, much less that they were all racing away from each other. From what was known up to about the 19th century, it seemed very reasonable that the universe was infinitely old and unchanging. And in such a universe, Olbers' paradox is a real problem. We now know, however, that the universe is not infinitely old and static. The universe had a beginning, given birth by the Big Bang. This has important implications for Olbers' paradox. Because the universe has a finite age, one reason our night sky is dark is that many photons have not had time to reach us. Those that have lie within our observable universe. This would not be so if the heavens had been around forever. The darkness of the night sky is a characteristic that argues against infinity. But the Big Bang presents us with another paradox. It states that the early universe was awash in photons. Everywhere, hot photons permeated space-time. At this time in our history, the cosmos was truly bright. Given these hot, bright early conditions, shouldn't wherever we look in the sky reveal the remnant of the Big Bang? Shouldn't there be a luminous curtain of light behind every star and galaxy we see? The fact is, this curtain of light is there, but our eyes cannot see it. Due to the expansion of the universe, the wavelengths of these hot, early photons have been stretched over 1,100 times longer than their original wavelengths. The high-energy, luminous backdrop of the early universe is today filled with relatively cool microwave photons, invisible to the human eye after being stretched by the expanding fabric of our universe for over 13 billion years. This curtain is currently being imaged by special detectors, some aboard the Planck Space Telescope, the most powerful microwave telescope ever built. It is giving us detailed views of what was once the brightest ball of energy ever known, the Big Bang. In the end, Olbers was correct, as was Digges, Kepler, Halley, and Poe. They troubled over the notion that the night sky should be as bright as the noonday sun, and in fact it is. What they didn't realize was that the night sky was only dark to us. If they had had eyes sensitive to microwaves, then there would never have been a paradox.